Okay, welcome friends, welcome again. And today I want to present to you a very fast and a short recap about what we learned on the previous session about how hydrostatic pressure increase will lead to the pulmonary edema. And this is our diagram of interest, which we will be studying on how the hydrostatic pressure in the pulmonary vessels, if it's less, would cause the pulmonary edema. And these are as one of the causes that leads to the increase the pulmonary hydrostatic pressure. Let's first define to you about what is hydrostatic pressure. The term hydro means fluid, and static means something that is not moving. It means the fluid that is at rest. So hydrostatic pressure, this is the pressure that is built up with the fluid. And for the case of the pulmonary hydrostatic pressure, it means this is the pressure that is generated by the fluid, which is a blood within the pulmonary vessels. So we are going to see on how if this hydrostatic pressure within the pulmonary vessels will increase, and then will cause the blood or fluid to move out from the lung vessels to the interstitial parts of the lung, and then it will cause interstitial edema. It will cause lung alveolar damage. It will cause an alveolar edema, and therefore generalized lung edema. Let's start with the first cause of the that will cause the increase in hydrostatic pressure within the pulmonary vessels. That is the heart failure. And when we are talking about the heart failure, we are directly focusing about the left ventricular failure. We know that the left ventricle is the chamber of the heart that pumps blood through the aortic opening into the aorta, and then the blood is distributed to the systemic parts of the body. So what will happen if there is a failure in this chamber? It means there will be a failure of blood to be pumped out to go to the other parts of the body. So it means the blood will accumulate here. If there will be accumulation of blood here, will build a pressure that will cause blood not to come on this chamber, and therefore the blood will build on the pulmonary vein, even on the pulmonary vessels of the lungs. Therefore the blood will accumulate. It means will be static. That's why we call it the hydrostatic pressure. It means the blood will accumulate within the lungs, and when the blood is accumulated within the lungs, therefore there will be a build of hydrostatic pressure, which will force fluid to move out of the lung vessels, and therefore entering into the interstitial parts of the lung, which will cause the interstitial edema or alveolar damage and alveolar edema. Another cause is the mitral stenosis. Mitral stenosis, it means the constriction of the mitral valve. What is the mitral valve? The mitral valve is a valve that separates the left atrium and the left ventricle. So if there will be a constriction here, it means the fluid or the blood will fail to go to the left ventricle, so as to be pumped to the other parts of the body. So it means the blood will accumulate in the left atrium, therefore will build pressure that will not permit the blood to come from the pulmonary vein, and therefore enter to the left ventricle. Therefore there will be accumulation of blood in the pulmonary vein, and therefore to the about wall lung vessels the blood will accumulate. as we see, the blood from the left pulmonary artery enter the lungs, and therefore after it has been oxygenated, it go to the pulmonary vein. From the pulmonary vein, it go to the left ventricle. So if there be a blockage here, it means the blood from there up to there will accumulate within the lungs, and the accumulation of blood here will build high hydrostatic pressure. The presence of high hydrostatic pressure will force the fluid to move out from these vessels and to go to the interstitial part of the body, and therefore will cause what we call interstitial edema and alveolar damage and alveolar edema, therefore generalized edema of the lungs. And another cause is the pulmonary vein obstruction. If there suppose the pulmonary vein is obstructed by an emboli here, if there will be obstruction here, it means the fluid will not be permitted to go to the left atrium and left ventricle to be pumped to the systemic part of the body. Instead, the fluid will accumulate in these vessels, will be static. And that's why we say it is a hydrostatic pressure. The fluid will be static over there. Therefore, the presence of accumulation of blood here will build high hydrostatic pressure, which will then force fluid to move out from these vessels, and therefore cause what we call pulmonary edema or alveolar edema. And the last cause is thyrotoxicosis. When we are talking thyrotoxicosis, it means there is impairment of the regulation of the thyroid gland function. We know the thyroid gland is the gland that is highly, very important in the metabolic rate of the body. So it means here, if there will be impairment in the regulation, there will occur what we call hyperthyroidism. The hyperthyroidism, it means there will be increased metabolic rate, rapid and high metabolic rate. Therefore, the presence of high metabolic rate due to hyperthyroidism will cause what we call left ventricular failure. What the left ventricular failure? Left ventricular failure or heart failure, which come after what we call tachycardia. Tachycardia means rapid heartbeat. So hyperthyroidism, it means it will cause rapid metabolic rate, and therefore will cause what we call rapid heartbeat or tachycardia. The tachycardia is what will cause the left ventricular failure or heart failure. Therefore, heart failure, especially on the left ventricle, it means it will lead failure of blood to be pumped out to the aorta and go to the other parts of the body. Therefore, what's for the pressure which will cause fluid to accumulate in these vessels. The accumulation of fluid in these vessels will at the end of the day will force out fluid to go to the interstitial part of the body after there is a building up of high pulmonary hydrostatic pressure. And thanks for listening, and this is the end of my presentation about this relationship between pulmonary hydrostatic pressure and pulmonary edema. Don't forget to subscribe my channel in order to get more updates of our videos. Thanks.